Alright, suppose you and I are asked to go rate some restaurants. Okay? And I don't know what they have. It's not important what they eat, but let's just call them restaurant number one, restaurant number two, restaurant number three, four, five, six, seven, 8 restaurants. And so there's J, and then there's U. Okay? So J and U. All right. Now, I really don't like this restaurant. I think it's crappy. I give it an 8. I feel like this one is a 5, 6, 2, 1, 3. Now, because I'm ranking them in order, so they have to all be accounted for. You agree with me, this one sucks. Do you feel that's that and that's that? Boy, we really disagree on that one, don't we? Ouch. Okay. Now the idea here is that is there any correlation? And remember, correlation, there's 2 R's in it, first of all, Jay. Is there any correlation or is there any relationship between how you rank and how I rank? And by the way, if there is, then when you say this restaurant's good, then I'll be like, I'm going to go eat there. That's cool. By the way, if it's a negative correlation, in other words, if we rank everything the opposite, and I say this restaurant's, and you say this restaurant's great, I won't go eat there because I'll know it sucks. Now, you may remember that back in chapter 10, we did correlation, and it was always between here and here. Well, this is a guy by the name of Pearson. That's his Pearson, Pearson. That's Pearson's correlation coefficient. And that's great, but that's the parametric version. But what about the non-parametric version? Okay. Well, this one also has a name. So then this is the parametric version. P, parametric, get it? Parametric. The spearman rank correlation is R, and your book uses the little sub s. Can also go from -1 to 1. -1 mean we completely disagree. If you rank it one way, I rank it 100% opposite. These are we completely agree. That's a 1 correlation coefficient. Anywhere in between, of course, if it's straight up, if it's 0, that'd be pretty weird if it was 0. If it was 0, though, what would that mean to me? Well, it would mean that we don't agree really, we're kind of all over the map with it. In other words, we're not 100% opposite, we're not 100% for, we're kind of all over the map. Okay? And so, the way that this thing is functioned, it comes out to be this. RS is equal to, and it's 1 minus 6 times the sum of the differences squared divided by n, and then n squared minus 1. And again, I use double parentheses to make sure it gets in the denominator correctly. I hate seeing people make dumb mistakes. Now up here, if we take j minus u, we get 0, -1. What if I subtracted it the other way? It won't matter because in a minute we're going to square these guys anyways. It would make sense? So regardless of what you get, you can end up squaring them anyway. So you get 0, 1, 1, 1, 1, 0, 16, and 9. That's 25, 26, 27, 28, 29. 29. Uh-huh. Uh-huh. So 1 minus 6 times 29 over, there were 8 restaurants, so 8 times, that's 8 times 8, 64 minus 1 is 63. And again, I have routinely done this in Excel in the past because, well, let's face it, I rather enjoy Excel. But if you don't, you're welcome to do it this way. All good. One minus that is that 0.65. Now, you'll recall that in chapter 10, we did a t-test to see if this guy was significant or not. Okay, well, there's actually a table for these correlation coefficients, and it's in the back. It's on page. It's in table L in the charts there in appendices number C and L. Now it says. So it says if the absolute value of your test statistic is greater than that in the table, we're going to reject H naught. Okay? So if I'm using 0.05 and I have 8, I get 0.738. So I get a critical value of 0.738. Now remember, this is plus or minus. The idea being here is it's not a Z chart, but you can envision it like this in your head. 0.738, of course, zeros here. 0.738 over here, and we are in here. What does that mean? It means there's no significant relationship between my rankings and your rankings. So H naught is that rho equals 0. There's no relationship versus, okay, it's not equal to 0, which means there is a relationship between our rankings. Again, if it was such that when we did our rankings, they're completely bass-ackwards, and I work with a person like that, I'm not going to mention her name, but I do work with a person that's very similar to that, and pretty much if I rank them this way, I can almost guarantee, oopsie daisy, darn it, and of course she's thinking the same thing about me, and that's just how it goes, and I'm okay with that, because we are all different people. But you know people like this. You know you do. You know, you know that if, I'm going to do it like that. I'm going to do 2 birds with 1 stone. 2 birds, 1 shotgun blast. Whatever. There it goes. Geez, those are big numbers, Jay. I know, right? So 1 minus parentheses 6, which is part of the formula, times, fiddle fart. Well, I'm going to click on that number for right now, and then I'll come back and show you what I'm going to do. And then it's n, which is 8 again, times 63 again, because that part's the same. And you're like, it doesn't matter, but hey, wait, let me do this equals sum. I forgot to add up that column, because I talk too much and don't pay attention to what I'm doing enough. There we go. Look at that. We 100% disagree with each other, and the correlation's -1. Hey, who saw that, right? Now, if we agree with each other 100%, and let's say she's right, so I'm going to change my way of thinking around, it's +1. That's right, baby. And so anywhere in between, there's going to be some kind of combination thereof. And that's how life goes. It's never going to be perfect. If it is perfect, just like in chapter 10, someone's probably been screwing with you a little bit. That's weird, okay? Now, if you talk about the number of repairs, there's an I in there somewhere, friends. There it is. First year that you own a car. Yeah. Good news, though. I found out today I am getting my tablet back tomorrow. Yeah, I thought it was today. It's not. It's tomorrow. I missed it a little bit. Finally getting just about... Okay. Getting cocky there for a minute. I was just getting used to this goofy old system, but I'm glad I don't have to get too used to it. That's close enough for government work. And the price of the car. Now, one would think that if you buy a cheap car, you're going to have to be in the shop a lot. And, I don't know, 6 times. And then $12,000, 3, and $20,000, 3, and $25,000. I can hear my friend already. Because it's a Honda! Okay, cool, great, good for you. I swear it's because it's a Honda! Okay, I heard you the first time. Mm-hmm. All right, and moving right along, and then $50,000. Jeez, it's a Mercedes. Mm-hmm. And whatever. Okay. Now, if a person wanted to do this problem here, well, one would probably pull up Excel, and one might be tempted to then grab a new sheet because it's what we do. Give me a sheet, people. Where's my new sheet? There we go. Boom. And I'm going to go ahead and input these in there. Okay? And so these will be the repairs. And 6, 3, oop, that's a 5. Try again. It's a Honda. I'm going to leave a blank between them for a reason I hope will become clear in a minute. I'm going to go ahead and make these into dollar signs. I have a hard time without my glasses on, which I know is lame. Counting how many zeros I have. And I don't know why that is. I mean, I know I could get my glasses, but that's too hard to do. They're clear across the room in a bag. Too lazy. I don't care anymore. And 40,000. Boom. So what I'm going to do is I'm going to rank these. Rank dot average. I'm going to rank this guy, comma, against this group of people, including himself, comma 1. Drag it down. Do the same thing for the prices. Because the person thinks, look, I spent the most money on this car, I should have the least amount of repairs. Yes, that's what a normal person would think anyway. Of course, they might be wrong. But the idea here is that, if there's a correlation, that would mean what? That would mean, if it's a positive correlation then, the more money I spend on my car, the more repairs I'm going to have to make in the first year. If it was a negative correlation, and a strong negative correlation, the more I spend, the fewer the repairs will be. Okay? There it is. So what I'm going to do is I'm going to take and find the difference between this rank, the rank for the repairs, minus the rank for the price. And again, it doesn't matter which way you subtract, because you're going to get the same answer when you square it. I'm going to find that sum. What just happened? That's weird. Oh, no, it's not weird. It just felt weird. Okay, it just felt weird for a second. No, that's right. Good for us. 36.5. So then it's going to be 1 minus parentheses 6 times that guy, divide by, and then there were 7 times, and then now it's 7 squared, which is 49, minus 1 is 48. Boom. I get a 0.34. Now, 0.34 for a correlation doesn't seem very big. That's your first thought, and you're not wrong. Okay, we'll look that up in a chart in a minute. Remember, H naught is there is no correlation. Now, what does that mean this time? There is no correlation between price and, I guess, quality. I guess what you could think of, right? Between price and quality. And maybe I write initial quality. By the way, if I spent 50 grand on a car, you better believe I'm going back in to have any little thing I perceive as a problem fixed. Set my radio. I just spent 50 grand. There is a correlation. So you'd have to make sure in a situation like this repairs. Define repairs, okay? Is it a situation where I saw a little string hanging off the leather on my seat cover? Fix that, okay? No, I'm talking about, like the water pump went out or some other goofy thing in the first year. So, again, that's always something you have to be careful of in statistics is, define what a repair is. Now, it may seem obvious to you, but it isn't always obvious. So, here's the deal. For 7, which is how many different cars we looked at. That's n equals 7. We had 0.786 is our critical value. 0.786. So again, if you want to draw a picture to kind of envision it, negative 0.786 on one side and positive 0.786 on the other side. We are in here somewhere. And what does that mean? It failed to reject. There is no correlation between them. Okay? Pretty easy to do. Makes a lot of sense in a lot of ways. Also, it makes sense that this would not necessarily be normal-ish because these two expensive cars and then that one really cheapo car maybe didn't have as good a quality / perceived quality for what I paid for the vehicle. Okay? And so, the $10,000 car probably is falling apart. The $50,000 car may not be falling apart so much as the 22, well, it would have been in the old days, the 22 disc CD changer isn't playing the 21st disc correctly or something, or God forbid, yes. So little piddly diddly things. Be careful of that, okay? But that's the gist of this Spearman rank correlation. It's pretty straightforward. I highly recommend that you figure out how to run the Excel like I showed you and then run with that. That to me is the easy way to fly. Boom.